So today we're going to be going over 2.4, which is biconditional statements and definitions. The objective of this lesson is to write and analyze biconditional statements. Vocab in this lesson is biconditional statement, definition, polygon, triangle, and quadrilateral. So when you combine a conditional statement and its converse, you create a biconditional statement. So we know a conditional statement is if P, then Q. The converse of if P then Q would be if Q then P. So to create the biconditional statement, we would combine the two. So a biconditional statement is a statement that can be written in the form P if and only if Q. This means if P then Q, which would be this one, and if Q then P. So we can write a biconditional by giving it arrows pointing to the left and to the right. We say the biconditional as P if and only if Q, and it can also be written as P and then an if with two F's. So this means P if and only if Q, or P if and only if Q. So example 1, write the conditional statement and the converse within the biconditional. An angle is obtuse if and only if its measure is greater than 90 degrees and less than 180. So first, let's identify the P, which would be an angle is obtuse. That's our P. Now let's find our Q. If its measure is greater than 90 degrees and less than 180. That's our Q. So this is asking us to write the conditional statement. So if we wrote P then Q, we would write this as if an angle is obtuse, then its measure is greater than 90 and less than 180. So that is our conditional statement, if P then Q. Now we're going to write the converse, which is Q then P. So the converse would be if its measure is greater than 90 and less than 180, so I'm just going to write greater than 90 degrees and less than 180 degrees, then an angle is obtuse. So in black here we have the conditional, and in green we have the converse. So here's another example. Write the conditional statement and the converse within the biconditional. So it's giving us the biconditional here. So we need to write the conditional statement and the converse. So we have a solution is neutral. That is our P. Its pH is 7. That's our Q. So we write the conditional statement as P, then Q. So we'd write this as if a solution is neutral, then its pH is 7. So we're just writing our P, and then we're writing our Q. So now let's write the converse. So in the converse, we flip them. So we write Q, then P. So this would be if its pH is 7, then a solution is neutral. So we have our conditional statement here, the first one, and then our converse is the second, which is if Q, then P. Write the conditional statement and converse within the biconditional. So the biconditional is given. So we have an angle is acute if and only if. This means if and only if its measure is greater than 0 degrees and less than 90 degrees. So our conditional statement is if P, then Q. So let's identify our P, then Q. So our P would be an angle is acute, and our Q would be its measure is greater than 0 degrees and less than 90. So our conditional is if an angle is acute, then its measure is greater than 90. Greater than 0 degrees and less than 90. So that's our conditional statement. Now let's write the converse. So in the converse, we flip the P and the Q. So we write if Q, then P. So our converse would be if its measure is greater than 0 degrees and less than 90 degrees, then an angle is acute. So we have our conditional, if P then Q, and our converse, if Q then P. Write the conditional statement and the converse within the biconditional. So this is our biconditional, because it says if and only if. So we have our P, which is Chow is a member, and our Q would be he has paid the $5 dues. So we'd write the conditional statement, which is if P, then Q, which would be Chow is a member, then Q, which is if, so it would be then he has paid the $5 dues. So P then Q would be if Chow is a member, then he has paid the $5 dues. Now we write the converse, which we flip the Q and the P. So if Q, then P. So we write if he has paid the $5 dues, then Chow is a member. So we're taking the biconditional and splitting it up into a conditional statement and the converse statement. So for each conditional, write the converse and biconditional statement. If 5x minus 8 is equal to 37, then x is equal to 9. So we have our P and our Q. So our converse would be flipped, so we'd write if Q, then P. So the converse would be if x is equal to 9, then 5x minus 8 is equal to 37. Our biconditional would be combining the conditional statement and the converse. So we would write 5x minus 8 is equal to 37 if and only if x is equal to 9. Let's look at B. If two angles have the same measure, then they are congruent. So we have our P. If two angles have the same measure, and our Q, then they are congruent. So our converse would be Q then P. So we flip them. If they are congruent, then two angles have the same measure. The biconditional, we combine them. So we would say two angles have the same measure if and only if, remember this stands for if and only if, they are congruent. So in the biconditional, we drop the if and then, and we put in the middle if and only if. So we have our P, if and only if, Q. For the conditional, write the converse and biconditional statement. If the date is July 4th, then it is Independence Day. So we have our P. If the date is July 4th, then it is Independence Day. So our converse would be the flip. If Q, then P. So we'd write if it is Independence Day, then it is July 4th. Our biconditional, we would combine the two. So we write the date is July 4th if and only if it is Independence Day. So we drop the if and we drop the then. And in the middle we put if and only if. So the date is July 4th, if and only if it is Independence Day. Write the converse and biconditional statement. If a point lies on the same line, if points lie on the same line, then they are collinear. So we have our P, if points lie on the same line, and our Q, they are collinear. So the converse would be the flip. If points are collinear, then they lie on the same line. So the converse is if Q, then P. Now our biconditional, we combine the two. Points lie on the same line, if and only if they are collinear. For the biconditional statement to be true, both the conditional statement and its converse must be true. So the conditional statement meaning the P then Q must be true, and the converse means that the Q then P must be true. If either the conditional or the converse is false, then the biconditional statement is false. So for an order that the biconditional needs to be true, P then Q has to be true, and Q then P has to be true. Determine if the biconditional is true. If false, give a counterexample. A rectangle has side lengths of 12 centimeters and 25 centimeters. If and only if its area is 300 centimeters squared. So let's look at the conditional and the converse. The conditional states, if a rectangle has side lengths of 12 centimeters and 25 centimeters, then its area is 300 centimeters. So what's the formula for area of a rectangle? 12 times, so length times width, 12 times 25, which would be 300 centimeters squared. So that's true. If a rectangle has lengths of 12 centimeters and 25 centimeters, then its area is 300. That's true. Now let's look at the converse. If a rectangle's area is 300 centimeters squared, then it has side lengths of 12 centimeters and 25 centimeters. The converse is not true because we could have a rectangle with a length of 30 and a width of 10. And if we multiply 30 and 10, we would get 300 centimeters squared. So a rectangle's area is 300 centimeters squared. It doesn't mean that it has side lengths of 12 centimeters and 25 centimeters. So this would be false. And this would be our counterexample. A rectangle with a length of 30 and a width of 10. Determine if the biconditional is true. If false, give a counterexample. So a natural number n is odd if and only if n squared is odd. So if a natural number n is odd, then n squared is odd. So if we have a natural number, an odd natural number, let's say 5. What's 5 squared? 25. If we have 7, what's 7 squared? 49. 9 squared? 81. All of these numbers are odd, so therefore the conditional is true. Let's look at the converse. If the square n squared of a natural number is odd, then n is odd. So let's look at all of these squares. So 25 is 5 squared. 5 is the odd. 49, 7 is odd. 81, 9 is odd. So the converse is true. So therefore, if we have the conditional is true and the converse is true, then the biconditional is true. The biconditional is true. So determine if the biconditional is true. If false, give a counterexample. An angle is a right angle if and only if its measure is 90 degrees. So our conditional would be if an angle is a right angle, then its measure is 90 degrees. If we have a right angle, that means that its measure is 90 degrees. So the conditional would be true. Now let's look at the converse. If the measure of an angle is 90 degrees, then it's a right angle. That's also true. So therefore, our biconditional, the whole thing, would be true. Our biconditional is true because the conditional is true and the converse is true. Let's Determine if the biconditional is true. If false, give a counterexample. Y is equal to -5 if and only if y squared is equal to 25. The conditional is if y is equal to -5, then y squared is equal to 25. -5 squared is 25, so that would be true. Now let's look at the converse. If y squared is equal to 25, then y is equal to -5. So we can also have y is equal to 5 because 5 squared is equal to 25. So therefore this would be false. So even though our conditional is true, our converse is false, our biconditional, the whole thing would be false. And our counterexample would be y is equal to 5. Because when y is equal to 5, it proves that the converse is false. In geometry, biconditional statements are used to write definitions. A definition is a statement that describes a mathematical object and can be written as a true biconditional. So in the glossary, a polygon is defined as a closed plane figure, so it has to be closed, formed by 3 or more line segments. So to the left, we have all these polygons. We have a triangle, a trapezoid, a square would also be a polygon, a rectangle, and then these are not polygons. So a triangle is defined as a 3-sided polygon, and a quadrilateral is a 4-sided polygon. So think of quad is 4. So a quadrilateral would be a square, a rectangle, trapezoid, rhombus. Think of definitions as being reversible. Postulates, however, are not necessarily true when reversed. Write each definition as a biconditional. A pentagon is a 5-sided polygon. So we would write this as a biconditional by saying a figure is a pentagon if and only if it is a 5-sided polygon. A right angle measures 90 degrees. So we would say an angle is a right angle if and only if its measure is 90 degrees. So write each example as a biconditional. A quadrilateral is a 4-sided polygon. So a helpful hint is if it gives you the word is, this would be the first part before the if and only if, and this would be the second part. So a figure is a quadrilateral if and only if it is a 4-sided polygon. So now let's look at 4b. The measure of a straight angle is 180 degrees. So there we see the word is. So we would put if and only if here. So we would have an angle is a straight angle if and only if its measure is 180 degrees. So we have what's left of the is as the first part, and what's to the right of the is as the second part. Last slide, yay. For the conditional, if an angle is right, then its measure is 90 degrees. Write the converse and biconditional statement. So we'd write the converse. If this is P then Q, the converse would be Q then P. So we would start with the second part. So if its measure is 90 degrees, then an angle is right. So that's our converse. Now let's write the biconditional. We drop the if and we drop the then, so we would just write an angle is right if and only if its measure is 90 degrees. So remember, a biconditional statement has to have if and only if. Determine if the biconditional two angles are complementary if and only if they are both acute is true. If false, give a counterexample. So in order to prove that the biconditional is true, we need that the conditional to be true, P then Q, and the converse, Q then P. So our conditional would be, if two angles are complementary, then they are both acute. So if we have two angles that are both complementary, meaning they add up to 90, if two angles add to give you 90, both of them have to be less than 90. So therefore, P then Q is true. Now let's look at the converse, Q then P. So if both angles are acute, then the two angles are complementary. So if we have two acute angles, let's say we have 30 degrees and 20 degrees. These are both two acute angles. Do they add up and give you 90? No. So therefore, the converse, Q then P, would be false. So our biconditional would be false, and our counterexample could be the two acute angles, 30 degrees and 20 degrees. Write the definition. An acute triangle is a triangle with three acute angles as a biconditional. So our biconditional needs to contain if and only if, and our definition has the word is in it, so we can put the if and only if right there. So we have a triangle is acute, if and only if a triangle with three, if and only if it is. So remember, we have to make the biconditional statement sound like an actual sentence. So we would say, a triangle is acute if and only if it is a triangle with three acute angles. So this is everything you guys need to know for 2.4. don't forget you guys have homework that's due tomorrow, so if you have time left at the end of class, you can get started on it.